That's like probably all you're gonna get. Actually, I want to switch hands. I'm left-handed, so it's weird to hold two things at once. I have to figure out which hand is better. I hope I didn't confuse the AI starting with hola. Before we get started, I want to say thank you to all of the organizers for inviting me here to speak today. It's my first time in Brazil, and I've had a lot of fun. And thank you to everyone in the audience for coming, because otherwise I would just be speaking to Aaron and John, and they hear me talk all the time. I'm Eileen Uchitele. You can find me anywhere online at Eileen Codes. I have a blog at eileencodes.com that I have not written anything in a long time. And I'm also on Twitter at Eileen Codes. I will not call it by its new name. It is Twitter forever. I work at Shopify as a senior staff software engineer on the Ruby and Rails infrastructure team. For years, Shopify has been heavily investing in Ruby and Rails, and I'm proud to work somewhere that deeply cares about our community. I've been contributing to Rails since 2014, and I've been a member of the Rails core team since 2017. The core team is responsible for the future of the framework, and we work together to plan new features and releases so that you all can have new stuff for your applications. When you've been working on Rails for as long as I have, you start to take for granted how the framework is designed and built. From the outside, Rails seems like a big black box full of secrets only a few know. It's difficult to find your way around the codebase. Through the maze of gems, it often feels like you're lost without a map. While Rails might look like a mess from the outside, it's actually a deliberate, complex, and beautiful framework. It's not designed to be perfect or solve for every use case. Of course, it has flaws like any other framework. The premise of Rails is to provide a more complete experience compared to other ecosystems. Rails was built to empower developers and unlock our productivity. Today, we're going to explore the magic of Rails. We'll look at the philosophy behind the framework, as well as the overall structure of the components. We'll explore some of the common patterns that Rails uses to build agnostic and beautiful interfaces, and the techniques that it implements to hide complexity so you can stay focused on building your application. By the end of this talk, you'll feel more confident navigating the Rails codebase and understand the patterns it uses to create the framework we all know and love. But Rails is also so much more than its design and architecture. We'll dive into why the community is so important to the long-term success of Rails. So what is Rails? When I ask this question, I'm not asking what the technical definition of Rails is as an MVC framework, but rather what makes Rails seem like magic. What are the driving principles behind its design, and what sets Rails apart from other frameworks? To start, Rails is modular but not fractured. While the framework is a set of components, we should be careful not to confuse modularity with lacking cohesion. In the early days, Rails used to be tightly coupled, and it was difficult to use one component without the rest of the framework. When MERB and Rails merged in 2008, it changed the architecture of the Rails framework, and from that day forward, we had built-in modularity and clear lines of responsibilities between gems. Today, we continue to maintain strict rules for each component and what other components they are allowed to depend on. For example, active model only depends on active support, and we will not accept changes that break that contract and add more dependencies. We want developers to be able to choose between using all of Rails or just what they need. This empowers Sinatra and Hanami users to use active support if they desire, while ensuring the framework is bundled as a cohesive code base by default. Rails is designed to have agnostic interfaces. While the framework provides a set of defaults for applications, we don't require you to use the tools that we've built in support for. We accomplish this by building interfaces that are agnostic to the tool being used. If you don't like Minitest, you can use RSpec without much effort. If your application requires SQL Server instead of one of the default supported databases, you only need to add the gem and update your database configuration. Active Record does the rest. We've implemented similar interfaces for file upload services in Active Storage and job queues in Active Job. These agnostic interfaces require that external gems work with our provided APIs. but the upside is that it empowers you to make decisions about your application. And the best part is you can change your mind mid-development without rewriting all of your existing code. The Rails framework is unique in that a lot of its functionality has been directly extracted from existing production applications. The very first iteration of the framework came right out of Basecamp Classic. Since then, we've upstreamed multiple database behavior from GitHub. Sharding functionality was influenced by Shopify's monolith. And many of the other features have been upstreamed from our applications. Because we build and design Rails based on the real needs of production applications, we can ensure that new features in the framework are stable, resilient, and performant. We test out APIs in our application to see how they look and feel before they become a permanent part of the framework. This is especially important because once a feature is released, it can't be removed or changed without deprecation. We want to avoid unnecessary churn or APIs that don't feel quite right. Extracting functionality we've proven out in our applications is a great way to build reliable and solid APIs. There's one thing that's hard to deny, and it's that Rails Rails has aesthetic taste. You might not love the aesthetic, but it's easy to see that Rails aims to create beautiful, simple, self-documenting APIs. The core team spends a lot of time debating the interfaces that applications will consume. We will endlessly discuss the right words and how to use them, not because we love bike shedding, but because we want new features to feel like they belong in Rails. The framework's interfaces are not accidental, they're deliberate and focused on look and feel. You might be wondering, though, if Rails cares so much about aesthetics, then why is the codebase so difficult to navigate? Why is it easy to get lost in the framework internals if Rails cares so much about your experience? Well, this is because Rails cares more about your application than it does about its own internals. The framework will gladly take on complexity so that you don't have to. To build your application, you don't need to know how to parse the database YAML or connect to those databases, how to talk to WebSockets, how to implement a test harness, or how to build an image uploader. Why should you need to write the same boilerplate functionality for every application you build? Why should you even need to think about the MySQL command for creating a database table when all you really want to do is get up and running for your future customers? Rails will handle all of this and more for you so that you can focus on building your application. The way Rails hides complexity is a feature, not a bug. Rails, of course, is not defined by these defined by these 5 tenets, but they represent the motivations and goals of the core team and how we think about the framework. The architecture of Rails didn't happen by accident. The way it's built is a deliberate choice to abandon certain ways of doing things in order to optimize for the human experience of building web applications. Because of everything Rails tries to do for you, the code base is incredibly difficult to navigate. There is no one person on the core team who understands how every part of Rails works, but because we all understand the patterns that govern development, we can usually figure out how any part of the framework is implemented. Once you understand how it's designed and architected, finding your way around becomes a lot easier. Rails is made up of 12 components seen here. The first version had just 4 gems: Active Record, Action Mailer, Action Pack, and Rails Ties. Out of the 12 current components, 4 are those original, 3 are extracted from them, and 5 are brand new additions. The decision to add new components doesn't happen often. We want to be mindful about what does and does not end up in the framework because anything we add needs to be maintained by the core team. There's only 12 of us, and while that sounds like we have 1 person per component, it doesn't quite work out that way. Everyone on the core team does have an area of expertise, but none of us are the owner of any particular component. And some of us have overlapping expertise. One of the things that comes up often when talking about how Rails is designed is what's the significance between the naming convention? Why are some gems prefixed with active and others with action? And you might be wondering, why does Rails Ties not even follow that convention? Well, the libraries that are prefixed with active are generally ones that support backend behavior. These include Active Record, Active Support, Active Model, Active Job, and Active Storage. They are responsible for doing things behind the scenes. The naming convention was originally influenced by the Active Record pattern, which Active Record is named after. It made sense to use the same prefix for other backend components. DHH wanted all of the gems to follow a similar naming convention, and so action followed active to indicate parts of the framework that are user-facing behavior, where a user makes an action. These are action mailer, action pack, action view, action cable, action text, and action mailbox. The rule for how to name a framework is a bit blurry. You could argue that action cable is not nearly as user-facing as this diagram implies, but hardly any name for something is perfect. Lastly, the piece that ties all of the frameworks together is called rail ties. A railroad tie is one of the cross braces that supports the metal rail on a railroad track. So it makes sense that rail ties would not follow the active and action naming convention, since it's the part that ties everything together. Rail ties defines the rail's constant and is our entry point into an application. While rail ties is the core of the framework, none of the gems and rails depend on it. This is what allows you to use parts of the framework you want without committing yourself to using all of Rails at once. The modularity of Rails is a conscious choice to give you the freedom to use only what you need. Rails implements a bunch of common patterns and techniques to build the interfaces and APIs that applications will consume. Ruby on Rails makes heavy use of factory patterns, inheritance, metaprogramming, and it uses a series of hooks and callbacks to control the load order of components and their configuration. Navigating Rails code can be really difficult because it's taking on a lot of complexity in order to provide consistent interfaces and simple APIs. However, the techniques that Rails uses enables the framework to provide an application development experience unmatched by any other framework. Let's first look at how components interact with rail ties to get a better sense of the role it plays in initialization and how it ties the framework components together. The entry point from an application to a component is rail ties. Any gem that needs to hook into the initialization process will contain a file called railtie.rb. This is where we define the load hooks for the framework, which will apply application configuration and settings. In addition, the config environments and config initializer directories are how your personal application hooks into rail ties and those components. Not every component implements a rail tie. It depends on whether that gem needs to extend or modify the initialization process. External gems that need to interact with initialization and boot, as well as configuration, will also provide a rail tie. Think of it as an API for hooking into Rails during the boot process. The rail tie functionality in a component can only be used within a Rails application. If you're using Active Record with Sinatra, for example, you're going to need to apply a configuration yourself. This means that some of the things that just work out of the box with Rails need to be manually implemented if you're using a component outside of the framework. Let's look at an example of how rail ties hooks works. When you boot your Rails application, rail ties will register the load hooks for each component from the defined initializers. Then it waits until each component is loaded, and once it's done loading, the hooks that were registered before the application was booted will then be run. In general, rail tie initializers are run in the order that they are defined. Therefore, anything in your application is going to run last, after the Rails initializers. This functionality also makes boot time faster by enabling lazy loading of Rails application components. Let's take a look at some code to see how this works in practice. If we look at the railtie.rb file in any of the components, you'll see they define a bunch of initializer blocks that look something like this. If we take a look at the method definition in Rails, we can see the initializers take 2 arguments, a name and an options hash. I guess technically it takes 3 because there's a block, but whatever. You don't really pass that. The name is simply an identifier, and the only options that are accepted are before and after, which can be used to control the order initializers are run in. These are used very rarely. In most cases, we don't set any options because we want the initializers to run in the order they are defined. However, before and after can be useful if one component's initializer needs to run after another one's. Initializers take a block which returns the application we're working on. This can be used to interact with the methods defined on the application object or access the config object as seen here. Within these initializer blocks, you'll often see an onload hook that tells Rails to register an action but wait until a specific component is loaded to call the code inside the initializer. Onload hooks enable the ability to apply configuration lazily by registering a hook that will be called when the library is loaded. The initializers are often used to set up the required functionality as an application boots. For example, if you've ever used Active Record outside of Rails, you're going to need to call established connection yourself. However, in a Rails application, the connection's already established for you. So where does that initial connection happen? In an initializer, of course. If we look in the Rails.rb and active record, in the active record component, we can find the we can find the initializer that is responsible for establishing connections to active record base when we boot our Rails application. The name of the initializer is active record initialized database. Because we have an onload hook, the initializer will not run until the active record component has finished loading. When this code is run, it will first find the database YAML from the application's path and parse the ERB. It will then pass the result to active record base configuration setter. This turns the YAML into database configuration objects. Once the database configurations are set, established connection is called. And that's it. That's how Rails sets the configurations up and establishes the initial connection. Establishing this connection for you is just one of the many things that Rails does when you boot your Rails application. Initializers also let us avoid calling components if they aren't included in a Rails application. Here's an example of that. In this initializer, we can see that active record will include controller runtime module only if action controller is loaded, and will include the job runtime module only if active job is loaded. If an application doesn't have action controller or active job, then these modules will never be included in the application. This avoids requiring applications depend on either of these components. While these are all really simple examples that fit on my slides, there are plenty more complex examples of initializers in Rails. The next time that you're curious what Rails is doing on boot, pop open one of the Rails.rb files in a component to find out. The important thing to take away from this is that Rail ties are the core of the framework, and it's what ties your application to each component. Most of the major components of Rails will implement a Rail tie to apply configuration and set up the application on boot during the initialization process. Without Rail tie initializers, we would have to do a lot more manual setup in our applications. The role of Rail ties is to handle configuration and initialization for you so that you don't have to think about all of these moving parts. Rails uses the initializers with onload hooks to control the load order and ensure that hooks are run at the right time. It prevents a component from being loaded too early, and it's also one of the ways in which we ensure Rails configuration doesn't override application configuration. Finally, Rail ties enables components to interact with other components without making them dependencies. Because the Rail tie waits until a component is loaded to call its code, we can define behavior for when a particular gem is available in an application. For example, active record, as we saw earlier, will only include job runtime module if active job is loaded. If it's never loaded, then we don't create this unnecessary dependency that forces you to use active job. While we only looked at a couple examples, this barely scratches the surface of the power of load hooks. The next time you're wondering where configuration is coming from, look in the Rail ties components for the answer. I have to switch hands. My arm is going to go to sleep. This thing is heavy. It's like I don't know what kilograms are, but it's like a good 5 pounds. Earlier, we talked about how Rails provides agnostic interfaces, which enables you to swap out default functionality as long as external tools implement the interface Rails provides. One example of this is how active record database adapters are implemented. By default, Rails provides support for 4 database adapters: Postgres, MySQL 2, Trilogy, and SQLite 3. Trilogy is a new adapter for MySQL that was originally built at GitHub. It's available in Rails 7.1 if you want to check it out. It has no dependency on libMySQL client, so you shouldn't have as many problems building it from source. If that's something you have to deal with, I do. If you look at Active Record's codebase, you'll notice that we never ever call ISA on the database connections adapter. This is because the database adapters are implemented in such a way that their interface is agnostic to the database client that we're using in our application. We achieve this by building an abstract adapter that implements the API. Then all concrete adapters inherit from that abstract adapter. The way this works is the abstract adapter defines the interface. You should never interact with the abstract adapter directly in your application. You should only interact with one of the concrete adapters. Each concrete adapter inherits from the abstract adapter and therefore defines the same interface through inheritance. The default behavior for each method is stored on the abstract class, since that defines the interface. Concrete adapters, including the ones external to Rails, are required to inherit from the abstract adapter to get that shared interface and implement the same public APIs. The pattern that we use to create agnostic interfaces means that in Rails, we can call a method like supports foreign keys, and we don't need to do an is a check. All the adapters will answer to the same methods. If a concrete adapter wants to have different behavior from the default, it can re-implement the method to change that behavior. As an example, here we have the definition of supports foreign keys for the abstract adapter. We can see that by default it's set to false. If we look at the Postgres adapter, this method is re-implemented and sets support foreign keys to true. The Trilogy, MySQL 2, and SQLite 3 adapters also all define this method and set it to true. The abstract adapter sets it to false because we don't know if external adapters that we don't control will be able to support foreign keys. This creates an interface where foreign keys are opt-in for any database adapter for Rails. Another place where we use this similar pattern to create agnostic interfaces is active storage. Active storage implements this slightly differently from active record. Here we have a class called service, which is equivalent to our abstract adapter. It's our abstract class that defines the interface. But instead of defining default behavior in that abstract service, it raises a not implemented error. This signals to external gems implementing an active storage adapter that they must implement this method for their service to work with Rails. If we open up the Google Cloud Storage service, we can see the implementation for the delete functionality. Every available service for active storage will implement this method in the concrete services, where the abstract service raises a not implemented error. The agnostic interfaces allows Rails to just call service delete with the key without having to check what service we're using. Whatever service we have set up in our configuration, Rails will call these methods and our service will just answer. Using this pattern reduces code complexity and makes it super clear what the interface is. We can guarantee that Rails will just work as long as the concrete service classes inherit from the abstract service and implement the specific behavior for each method. To recap, Rails uses abstract classes and inheritance in order to implement an agnostic and consistent interfaces for the services that we support. It also provides an easy way for library authors to build their own service or adapter. Rails implements an abstract class, which all concrete classes inherit from. The abstract class is responsible for defining the interface, and the concrete classes are responsible for changing behavior by redefining those methods. You will see this pattern anywhere in the Rails codebase where we need to implement a pluggable interface. One of the benefits of this pattern is it simplifies the Rails framework by avoiding calling ISA everywhere. We can assume that any call to an adapter or service will implement the interface that is defined. Anytime a method is called, Rails already knows how to respond. This also avoids undefined method errors for any external adapter or service. They can fall back to the default defined behavior or get a not implemented error to indicate they need to define that method. In addition to simplifying the Rails code, the patterns that we use to create agnostic interfaces make it easy for applications to swap out adapters. If you start your application with SQLite, you can easily switch to MySQL 2 by updating the gem file and database configuration. This applies to active storage services as well. If you don't like Google Cloud, you can switch to Azure by adding a gem and updating the storage config. Everything else just works. These interfaces allow us to provide a set of defaults without forcing you to be locked into what we provide if you want to use something else. Lastly, implementing a set of default interfaces for an external provider set of interfaces lets an external provider hook into, okay, sorry, I have the wrong slide. Lastly, implementing a default set of interfaces that any external provider can hook into lowers the maintenance burden for the core team. We don't need to know how every available service that exists works. Instead, we can provide the ones that we're comfortable maintaining and everyone else can build what they need outside. Rails is a big framework run by a small team, so we need to be sure that we're not taking on more of a maintenance burden than we can handle. Agnostic interfaces that implement a stable API for external gems allows us to avoid supporting an infinite number of providers while not locking you into our default options. In addition to the patterns that we've looked at, Rails makes heavy use of metaprogramming to achieve simple and beautiful APIs. Because of this, it can sometimes be difficult to find where behavior is defined in the framework. A lot of what you think of as Rails magic is powered by metaprogramming. While it can be difficult to trace code that uses this technique, it is essential to building APIs that are beautiful and hide complexity. There are a lot of examples of metaprogramming in Rails, but today we're going to look at only one example of how we use class eval to build the associations getter and setter APIs. Let's say we have two models, post and comment. Post has many comments, and a comment belongs to post. This is a pretty simple example that I think that all of us have written if we've ever made a blog in 15 minutes. Have you ever wondered how we're able to call post.comments without defining this method in our model? How does post know about comments at all? Active Record can't predict that you're going to add this to your model, so you know there's no way that Rails has a hard-coded comments method definition. Figuring out where this method is defined can be pretty difficult if you know where to look. When I don't know where something is defined in Rails, I use Ruby's source location method, which will give us the file name and line number of where any method is defined. We can find this definition of comments by calling method on post and passing comments as a symbol to it. This will work for any method defined on post. Then we can call source location, which will output the information that we need. If source location returns nil, it means that the method is defined in a C extension or C Ruby itself. That tells us the comments method is defined in association.rb on line 103. If we open that file, we can see that it points to a method in Active Record's association class called defineReaders. This method takes a mixin and a name. Using the mixin passed in, Rails will call class eval on it. Now, if we don't know how this metaprogramming works, we might assume that the mixin here is the post model class. However, it's actually a dynamic module named post-generated association methods that is dynamically created when the post model is loaded. This module is where Rails defines instance methods for the post model. This is important because the magic behind Rails comes from methods, classes, or modules that are dynamically generated when you boot your Rails applications, and your models are then loaded. It's not obvious that this is how associations work unless you spent a lot of time in the code. Okay, back to defineReaders. Inside the class eval block, a method is defined using the association name. In this case, it would be def comments. Active Record looks up the association from the association class and then calls the reader method on it. Using metaprogramming here lets Rails provide an API to access comments on post rather than forcing you to implement your own comments method or calling reader. The writer method has a similar looking definition, except that it calls writer and passes a value. You can see that these definitions are almost the same, but each are implementing a slightly different instance method. You'll also notice that class eval passes a magic file and line variable. This is a feature in Ruby that lets us define the file and line number for a metaprogrammed API to make debugging easier. This is what allows source location to work correctly. There are a lot more methods that are dynamically generated when working with associations in Rails, but we can't cover more of them today. My hope is that by showing you how we use one little bit of metaprogramming to build one simple and beautiful API, that this will feel less magical when you're working with an association in the future. Association accessors are just one example of how we use metaprogramming in Rails to provide an application with beautiful, simple, and clean APIs. Without utilizing this functionality, we would not be able to have methods like post.comments and Active Record. Metaprogramming makes Rails a lot more complex internally, but the trade-off is that it enables us to hide complexity from your application. The alternative would be running your own queries and defining your own comments, getter, and setter. That doesn't sound very fun, does it? Rails doesn't want you to have to do all that work yourself. We want to provide you with sensible, self-documenting, simple APIs that just work. It's the beauty of Rails, and it's where a lot of the so-called magic comes from. We use metaprogramming techniques throughout the framework like method missing, class eval, instance eval, define method, generated modules, and much more. Metaprogramming enables us to build interfaces for migrations, generators, so many of the things that you think of as features of Rails. While super powerful, this does make Rails internals more difficult to navigate. The trade-off is you get beautiful APIs, and you don't have to think about how these methods are generated. Rails just handles this for you. If this is all new to you, you're not alone. When I first started building Rails applications, I didn't know how any of the Rails internals worked. I had no idea how Rails was architected, the role that rel ties played, how we use metaprogramming, or how Rails uses common patterns to create agnostic interfaces. I had no appreciation for how Rails is designed and built. In my early days working on the framework, I had absolutely no idea what I was doing. I got stuck often, I made mistakes, I got frustrated, but I found learning how Rails internals work exhilarating. For me, Rails is so much more than just a framework. It gave me a career and it gave me a community. Rails isn't just code or the patterns that we looked at today. Rails is greater than the sum of its parts. Rails is inspiring. It brought us convention over configuration to help us eliminate boilerplate code. Rails, along with Django, popularized the MVC pattern. Rails inspired Elixir's Phoenix framework and PHP's Laravel framework. Even if you don't love Rails, which I hope you do since you're all here, and think we make weird or bad choices, you can't deny that it didn't influence so much of what we know as modern web development today. Rails is not just inspiring, it's empowering. Rails wants you to be productive, so we swept away all of the tedious problems like scaffolding and migrations and database connections so that nothing was in your way. Rails builds agnostic interfaces so that we can provide sensible defaults without locking you into what we think is best. We ensure that Rails is modular so that if you don't want to use the whole thing, you're empowered to just use the parts that you like. Do you prefer Sinatra but really want active record? Cool, you're empowered to do that. Want to write a simple script but you would love the datetime helpers from active support? There's nothing stopping you from doing that. There's a reason why we have a video of how to build a blog in 15 minutes. Rails wants to do everything it can to empower you to build quickly and efficiently while keeping complexity out of your way. Rails is also imperfect. I've spent a lot of this talk telling you how great I think Rails is and all the things it does for you, but I can't say it's without flaws. Rails aims to be a framework that meets 80% of users' needs. Rails doesn't try to do everything under the sun. Instead, it wants to make you productive by giving you almost most of what you need. But Rails is also imperfect because it's 20 years old. It's no longer an unruly teenager, it's a mature and stable framework. But sometimes maturity means imperfection because we can't just change functionality if applications depend on how it works today. Rails is imperfect because the people working on it are imperfect. We make mistakes, we add features we thought were a good idea at the time, we've broken builds, we've broken apps, we've created security vulnerabilities, but imperfection is a part of being human. Rails is also the applications we build. From small businesses to large enterprises, Rails powers so much of the applications we interact with daily. There are thousands and thousands of applications in the world using this framework, and they are just one piece of what makes up Rails. Rails is the team behind it. As a maintainer of Rails, my goal is to see the framework evolve and ensure the community of contributors continues to grow. The maintainers are the ones making sure that releases happen on a regular cadence, that features get merged, we assist new contributors, answer bug reports, help out in Discord. Without the 12 core team members and 27 other maintainers, we wouldn't have Rails as it is today. In the years since Rails has been open source, over 6,000 people have contributed to the framework. Every single person who has made a change to the framework is a part of Rails. And of course, Rails is the community. The community is not just the core team or just the framework, it's all of us. We make the community what it is. Without a community of users and contributors, Rails would just be Ruby code. But we all know that Rails is so much more than the sum of its parts. It's human-centered design, agnostic interfaces, and beautiful APIs that are extracted from applications. It inspires and empowers developers. It's imperfect and flawed. It's the applications we build, it's the team behind it, and it's the community. And maybe it's a little sentimental to say, but I actually think that Rails is magic. The role each of us play in Rails development community and future are what makes it magical. It's up to all of us to continue building this framework and community so that new people come join us and those that are here stay. Connecting with people is the reason that we are all here. It's what makes it worth it. I'm grateful to be back at conferences, meeting new folks and seeing old friends. We might have different goals, but we all care about the same thing, Ruby on Rails. I hope you'll join me in being an active and present member of Rails Future, whether that be through conferences, blog posts, mentoring, or contributing. Let's work together to ensure this framework and this community are something that we want to keep coming back to. Obrigado.